Hi everyone, and welcome to this video on arithmetic sequences, but we're going to look at some really tough IGCSE examples, not like the rubbish they give you in the textbook. They just spring these ones on you in the exam. But before, we're going to just warm up our brains on sequences. So here's a pretty basic sequence in front of us, and we want to find the 15th term. So we could add another 10 terms on just by doing it, but the cool kids, we find the nth term, okay, and that's how we write the nth term nice and quick. Now, what's it going up in? Oh, it's going up in threes. What else goes up in threes? The 3 times tables, and that's how we write the 3 times table. Now, if we continue this sequence the other way, you can see that we're taking away 3 each time. So if we did that one more time, we would end up with a 5, which is positive. So it's the 3 times table, but with 5 more added on. And you can see that is true because the 3 times table would be 3, add 5 is 8, 6 add 5 is 11. Okay, so that's pretty easy. Now to find the 15th term, we're going to find the 15th term. That's how we write it. It's quicker than writing this, right? So we're going to have 3 lots of 15 plus 5. We're just subbing in the 15 to the sequence. So and we get 50. Okay, 45 add 5. Now, the reason I've done this question is to warm up, but also to tackle this one, because I've seen it a lot and it's really badly answered because a lot of people panic. They go, what is that? Crikey. Sometimes it's only worth 1 mark, so it's not really a game changer. But if you look at the language, it hasn't changed from, if we call this one A and we call this one B, the language hasn't changed at all. Find the 15th term, find the n plus 2, should that be an ND there? I don't know. That term. So if it was 15, we popped 15 in. So actually, what we're going to do is just put n plus 2 in. Treat it exactly the same. So if it's a 10th term, we put a 10 in. 15th term, we put 15. n plus 2, put n plus 2 in. So, oh look, we've got a bracket. Let's just expand that bracket because that's what we always do when we see a bracket. Tidy it all up, and we have 3n plus 11. That is the n plus second, n plus, I don't know how to say that, term. Okay, so it's 3n plus 11. So to get into this zone of these hard questions, we've also got to be good at writing expressions for certain terms. Now if you remember from the previous video, we said the first term is A in an arithmetic sequence, and the second term comes about when we add a constant difference to it. So the third term would be another constant difference, which is a plus 2d. But we're not going to keep doing this all the time. We need to be really comfortable with realizing that you need to have one less than the number of terms, lots of the difference, okay? So the second term is 1 difference, the third term is 2 differences, so the 6th term had 5 differences. And for the same reason, the 10th would be 9 differences, and in a general form, it would be n minus 1d, and that is another formula for the nth term of a linear arithmetic sequence. Okay, I didn't need to say linear because it kind of means the same thing. Right, so here we go. GameFaces on. Question number 1 in the tough zone. So we've got 3 consecutive terms, so that means they one after the other, in an arithmetic sequence. Now you can see it's automatically harder because the numbers have gone. We've got algebraic expressions, and we're asked to find the common difference. Okay, well, because every term is just a d added on, what I can say is if I take 4x plus 5 and I take away 2x plus 3, I would find the common difference. So for example, if that was 5 and that was 7, if I did that, take away this one, I'd get 2. I can see the common difference. Now, that would mean this one would have to be 9, and remember I'm just making these numbers up to prove a point. It would be the same as saying 8x minus 3 take away 4x plus 5. Okay, so these two things are the same, so let's see what we get. So 4x take away 2x is 2x, 5 take away 3 is 2, and we've got 8x take away 4x, that's 4x, and minus 3 take away 5 is minus 8. So x is on one side, numbers on the other, x is 5. So that means x is 5, so what have we got here? We've got 13, then we've got 25, and then we've got 37. So you can see the common difference is 12. Now, that doesn't mean A is 13, because they could ask us to find A, but what would they have to do is say the first 3 terms in an arithmetic sequence are. And in that case, we've got A is 13. Loads of people stop at the 5 because they just think, oh look, I've worked out an equation, there's my answer. You've got to think about it. So all you've worked out is the key to unlock the sequence. We've unlocked the sequence here, and then we can see the common difference. And if it was the first 3 terms, 13 would be A. Right, okay. Bleh. This is horrible, isn't it? Look, hard to read as well, I apologise about that. So we've got the first term of an arithmetic sequence is 13. So let's write that down. A is 30. And the common difference is 1.5. So in fact, let's go ahead and write out the sequence. So that's going to be 28.5 because we're taking away 1.5 each time. Just do one more. And I'm going to put a few dots down there. So find the value of the 25th term. So I'll tell you what I'm going to do. I'm going to do lots of this up here as well. So let's find the nth term. So we know it's going to be minus 1.5n because it's going down in 1.5s. And what else goes down in 1.5s? The 1.5 times table, the minus 1.5 times table. If we continue the sequence on to this term here, we would get to 31.5. So there is my nth term. Nice and easy. And if you wanted to, you could have used this formula just by popping in some numbers, like popping in the A, popping in your D, expanding it all out, rearranging it. But what's the point when you can just do it in your head? So we want to find the 25th term. So what we're going to have to do is bung in 25 into here. Okay, just like the first slide really, just a bit more confusing. So 31.5 minus 1.5 times 25. Now you can type that straight in because your calculator is automatically programmed to do BIDMAS, so it'll do the multiplication first, which you want it to, and we get minus 6. Now, when you first write that, you might think, oh, that doesn't look good. But if it's going down, it's eventually going to get to negative numbers, right? Oh, I was just trying to shrink that, but obviously that didn't make it happy. Okay, so let's just do part B down here. So part B, it says the rth term of the sequence is 0. So like that could mean, well, it's going to be less than 25, yeah? Because 25th term is minus 6, it's gone below the 0. So let's, argument's sake, let's say it's the 23rd term. So it could say the 23rd term is 0. That's what we're trying to work out. So what we know is 0 is equal to my nth term. So where does this formula here, this nth term, give me 0? Well, just solve the equation. It's a linear equation, so n's on one side. Oh, but it's negative, so we're going to get the n's on this side. Literally because there's 0 here and minus here, so there's more actually on the left-hand side. And let's just divide those throughout. So 31.5 divided by 1.5, 21. So I'm glossing over some of what I'm doing really, like the maths I'm dividing, because if you're watching this, I do expect you to be able to solve a two-step equation. Right, so that's the 21st term. Right, so 21st term is equal to 0. Let's write that down too. So the sum of the first n terms of the sequence is, they just called it S, sum of n terms. Find the largest possible value. Well, that's a strange question. Now the only time they can ask you this question, and I've got this straight off of GCSE by the way, is if it's a descending sequence like this, because eventually, like we've seen here, it goes to negative numbers. So if we keep going along, the actual total is going to get smaller. So we just need to add it up until when it's 0, and we've just worked that out in part B. Okay, so well, in fact, we can either find the sum of the 21 terms, or we can find the sum of 20 terms. Because the 21st term is 0, I'm just actually going to find the sum of the first 20 terms, because you'll see in a minute it's going to make the calculations a bit easier. So let's write the formula that we talked about in the last video, the sum of an arithmetic series, and you're given it in an exam. So sum of 20 is n over 2, so 20 over 2 is 10. You can see why already it's easier. two A's, so we've got 60, plus 19 lots of minus 1.5. So I'm just going to type that in reverse. I'm going to type in 19 times minus 1.5. I'm going to do 60 plus that, and then I'm going to times that by 10. And I get 315. If you did 21st term, because the 21st term is 0, you should also get 315 as well, and you can prove that to yourself if you want to. Let's have a look at another one. Let me just flick ahead. Yeah, this is the last one, and this is pretty rank, so pause this as many times as you need to if you're going to make notes, but just maybe watch it through first. So we've got the sum of the first 6 terms, okay? So sum of 6 is 102. Now we've also got the 4th term, so that's the first term plus 3 differences is equal to 19. Find the starting number, so find A and basically D. Alright, so this, it will be the last question on an IGCSE, so it's mega hard. And it was dropped down from the A level, so don't worry if you do find this hard, but give it a go. So we've got sum, so let's write the formula. So we know 102 is equal to n over 2 lots of 2a plus n minus 1d. Alright, let's see what we can do. So we know 102 is equal to 6 divided by 2, which is 3. 2a, no idea, plus n minus 1, okay, that's 5, so 5d's. So let's divide everything by 3. So we've got 102 divided by 3, and I get 34. So I've got 34 is equal to 2a plus 5d. Alright, that's going to come in handy. Well, it's going to come in handy because we've also got another, let's get rid of those 2 lines, it's going to look confusing. We've got 19 is equal to a plus 3d. So we've basically formed 2 simultaneous equations, but let's just eliminate one. So if I times the second one by 2, I get 38 is 2a plus 6d's. Right? So we've got equation 1, equation 2. We've got the coefficients to be equal, so we can eliminate them. And let's subtract them. Let's do equation 2, take away equation 1. So we're going to get 4 is equal to d. And it's done. So now we know d. Let's sub it into this one, for example, because it's easier. So we've got a plus 3d, so a plus 12 is 19. Well, a must be 7. Let's just check that in this one. So we've got 14 plus 20. Bosh, it works.